Alright, you guys, first from yesterday, I want you to remember what an inverse operation is. So yesterday we worked with addition and subtraction. Today we're going to work with multiplication and division because they're inverse operations of each other. I also want you to be sure you have written down the steps to solve a one-step equation. So remember, we're going to locate the variable. We're going to determine the operation tied to the variable. Is it being added to, subtracted to, multiplied by, divided? We have to determine the operation because then we're going to use the inverse operation on both sides of the equal sign to solve. And then finally we worked on checking our solution. So today, let's start with solving equations with multiplication. So if we're solving them with multiplication, that means the variable is being divided. So our multiplication property of equality just like we had an addition and a subtraction property of equality is when you multiply both sides, whatever you do to one side, you have to do to the other, of an equation by the same number, the two sides remain equal. Alright, let's get right to it today, guys. So we have x over 3. Remember that means x divided by 3 equals 9. Now I'm going to show you how I would like you to show your work for this. Now, if we multiply, which is the inverse, both sides, we have to multiply them by 3. We have to undo what is being divided. Now, if I have 3 divided by 3, that's really just 1, right? So those would cancel out and we would have 1x. And then we would have 9 times 3, which is 27. So that would be our answer. Then when we are checking our work, we'd say 27 divided by 3 equals 9. Well, yes, 9 does equal 9, so that works. Our solution was correct. Okay? Let's try another. K over 11 equals 5. Well, over here we multiplied by what was underneath. So here we're going to do the same. If k is being divided by, the inverse of division is multiplication. So we are going to multiply both sides by what? 11. Because we want just 1k. And we know any number divided by itself is 1. So we have 1k over here that we just write as k. We know we can do that. Equals 5 times 11, which is 55. So there's our answer, but then if we're checking our solution, we would say 55 divided by 11 equals 5. 55 divided by 11 is 5. So it checks. You're showing all of your work. Hopefully you've been showing all of your work all week long, right? Alright, try this one on your own. Make sure you're pausing your video. M over 6 equals 7. And try 2 equals C over 8. Alright, what's being done to M? It's being divided by 6. We have to undo it by multiplying by that same thing. But whatever we do to the left side of the equation, we have to do to the right side of the equation. So this leaves us with 1m. If this didn't leave you with 1m, then you're doing something wrong. So if you happen to decide, oh, there's a 7 here, I'm going to multiply by 7, you would have 7 6m. So you'd be like, oh, wait, that's not right. I want 1m. So if these can't cancel each other out, you're doing something wrong. Equals 7 times 6. So then there's your answer. You're plugging it back in. 42 divided by 6 is 7. 7 does equal 7. Alright, make sure you're pausing your video, giving this last multiplication one a go. Alright, it's being divided by 8. So we would have to multiply both sides by 8. Not just the right, but both sides. Do not forget to multiply both sides. That keeps it remaining equal, the two sides. So 8 times 2 is 16. 8 divided by 8 is just 1, right? 1c. Then I could say 2 equals 16 divided by 8. 2 equals 16 divided by 8 is 2. So that works, okay? Bet you know where we're going from here. Alright, division property of equality. Division property of equality. So remember, when you divide both sides of an equation by the same number, the two sides remain equal. Okay, so we're going to be working with multiplication problems because division undoes multiplication. Sorry, I ran out of room on the bottom of that page. So here is number 5 for you. So 6y equals 24. Well, what's being done to y? Y is being multiplied by 6. To undo that multiplication, we have to divide both sides by 6. See how I'm showing it like this? This way I see, okay, now I have 1y. That's exactly what I wanted. 24 divided by 6 is 4. There's my answer. However, I would say 6 times 4 equals 24. 24 does equal 24 when I'm checking, right? So another look, 30 equals 2f. If multiplication is being done to f, I have to undo it with division. So I'm going to divide both sides by 2 because I want this number to be 1 in front of the f, so I can just write it as f. 30 divided by 2 is 15. So then I would check my answer. 30 equals 2 is 15. 2 times 15 is 30. So yes, that works. Alright, give these a go. 8n equals 8. And 63 equals 7p. If it's being multiplied by 8, we have to divide by 8, but both sides, right? So we have 1n, and 8 divided by 8 is 1. So 8 times 1 equals 8. Yes, indeedy. And if it's being multiplied by 7, we have to divide by 7. Both sides. 63 divided by 7 is 9. There's our answer. 63 equals 7 times 9. 7 times 9 is 63. You got it. Alright, give these last two a go. I know we're going a little bit long again. Nine and 10. So try this. X over 2 equals 7, and try 48 equals 8n. What are you going to do? Well, x is being divided by 2, so I'm going to multiply to undo it. I'm multiplying both sides by 2. 2 divided by 2 is 1x. That's just what I wanted. 7 times 2 is 14. So I would check. It works. I'm doing it in my head. I'm not just saying 7 times 7, yeah. You got to actually think through that, right? It's being multiplied, so I have to divide to undo it. So 6. Is that right? Let's see. 48 equals 8 times 6. 8 times 6 is 48. So it checks and it works. All right, guys. Have a fantabulous day.